Hey everyone, I'm Ashish. I would like to know if I'm audible or not. Could someone please confirm?
Yes, you are audible.
Oh, yeah, great. So I'm Ashish, and I'll be conducting this session on data science, intro to data science. And about me, I have around 8 years of work experience in the field of data science. And I started in around 2015. We were a team of three people. We started our own company, and basically it was about an IT firm, and we used to make and sell digital products like softwares, desktop applications, and stuff, and related services. And so my journey started back in 2015. But as a co-founder, you really don't know much about tech. So that's how my journey started. I didn't know that I would end up in data science. So for me, what happened was I just started with no idea of what to do. So as a manager, as a co-founder, you are the manager, you are the HR, and basically you are the employee and intern as well. So a lot of decision making happens at that stage. So in especially in positions where you are taking decisions, you are not really much concerned about the tech stack of your company. If you have guys have heard about Python programming languages, there are other languages as well. There are other analytical tools as well. So as a manager, you really don't care about what kind of tools you are going to use. As a manager, your perspective is to make profit for the company, bring in as much credit as possible. So that was it. So it was in 2019 specifically that I personally got into the field of data science, and I learned, okay, this is what programming is and this is how analytical tools are used. But not much has changed even for me. I used to make decisions prior to learning data science in 2019, but after 2019, when I learned the tools, I'm still using the same things. I'm still making the decisions. So the point is that when we hear about something like data science, we imagine that we will be doing like softwares like this kind. If I can show you, we would be dealing with softwares of these kind. When we imagine data science, we imagine that okay, we'll be using the data and stuff like that. But the point is, one thing is consistent, that even if it's the data, even if whatever happens, even if you're working on an application or stuff, decision making is always there. So I hope everybody is now and here, and basically that was more or less about me, like 8 years of work experience. And to sum it up, most of my experiences around the manager side of things. It was only in 2019 that I personally got into data science. But then again, I never intended to, get into data science. I hope my intro is clear. And then again, yeah, I would like this session to be very much engaging. So you guys, if you have, any kind of, at any stage, if you guys have any kind of question, just, open your mic and fire up. All right. So
Yes.
let's get started. So let me tell you a story of what happened around 1.5 years ago. Uh, it was around the time of winters, and I was working with a news channel, a local news channel. You guys might have heard about it, but I won't advertise that. So they launched a new product. It was conceptual at that point of time. So they already have a lot of customer base in India. So they wanted to analyze, okay, if this product is worth launching or not. So they already have like a lot of data. The company has been for more than a decade. So they already have the past data of their customers. They already know, okay, in which kind of states the news channel is perceived more. So they already have a lot of advertisement data as well. Like, okay, in which place if we advertise a certain product, where are people most likely to buy our product and stuff like that. So the point is, they came up with a new educational and awareness product. And what we worked on was we wanted to figure out, is this product worth launching? And if it is, then where are the places we can launch it? And due to the non-disclosure and stuff, I cannot get into the specifics of it. But I have, like over here, a very specific app, a case study, which more or less replicate the same thing. So I hope I'm clear at the moment.
Yes.
All right. So I have taken this case study from internet because it's open source data, and I can like use it for any kind of purposes. So the data set is about individual residences. So town one, town two, town three inside the state of California. So all I've done so far is, as you can see in the data itself, a lot of residential areas are given to you. Like if I zoom in, if you see, Let the map clear up. Yeah. So a lot of residential areas are given to you like this, and your objective is to analyze the house pricing of that particular residential area. And when you have a particular problem statement, the problem statements are very vague inside the data science field. Like you will hear me say data science, machine learning, deep learning, and AI and related technologies. But it doesn't happen this way that somebody would come up to you and say, okay, solve it using this way, or solve this thing using that way. Use Python to do this, use this software to do that. It doesn't happen that way. Usually what happens is people will come up to you, especially your clients. All they would do is they will say, okay, I want to increase my profits. Can you help me or not? So then comes your follow-up questions. Like, okay, I can help you, but follow-up question would be, could you provide me a little bit more about your data of your company and stuff like that? So we are taking a look at sample data. So we have latitude, longitude over here in the sample data itself. So this is about the town. One first town sample data, second town sample data, and so on. We have around 20,000 information, 20,000 town information, 20,640 to be very precise. So these are how many towns information we have available with ourselves. So look at the other columns as well, and just get the feel of the data first, because this is the starting point for this point of application. So let me use this thing to maybe more simplify this data. Yeah. So we have the geolocation of a particular residential area. What's the median age of that particular area, and how many rooms within that particular residential area, total bedrooms, and so on, population, household. And when you see this median income kind of thing, it's in the units of 10,000. And when you see this median housing age, so read it in this way, that we have in the first row of town, we have 126 houses, and the median age of those houses is 40 years old, or 41 years old to be very specific. So the point is, manually, if you were to read all the data yourself, initially you were given just this kind of data. As a human, you cannot read 20,000 rows of data by yourself. I mean, just answer me. Would you like to read 20,000 rows of data of Excel by yourself? Come on, guys. Any answer? Type in the chat, please. I would like this session to be more engaging. Yes, no? Chalo, I will still take the session forward, assuming that you guys are with me. So see, as humans, we are, not capable of reading through all the data by yourself. Like in this case, we have 20,000 examples, 20,000 residential areas. We are not going to read it one by one. So what we do is we use some kind of software like SAS, R, or Python. If you may have heard about these things, good. If you haven't, I will give you the intro today. So the thing is, we summarize that particular data and visualize it. And in this case, it was a geolocation data. So of course, I would make a Google Maps sort of thing over it and see entire information has been summarized in such a beautiful format. And as you can see, these individual markers. So all these markers are about the individual towns in California. I hope at this stage everything is clear, like what I've done so far. Taken the data and just visualize it. And if I expand on it, this is like one row of Excel. This is like another row of Excel. And if you could read the information, it tells you, okay, in this particular town, this is the population, this is the latitude, longitude, location. These are the median housing age, like 24, 26 year old are the houses in here. Total rooms, bedrooms, households, median income of people. And this median income is in the units of 10,000. So you can imagine it to be $19,000 per year, and median house value. So out of all the houses that are in here, 370 houses, 97,000 is the median house of that particular uh, in that house. So I hope you guys have an idea of what I'm talking here, and I will relate it to the real world example of that news channel that I was talking about. But can we do tell me that you guys are with me today, or if someone would like me to repeat it, please let me know.
Actually, you are talking about California housing set data set, right? Which we
Right?
in Google Colab for
Yeah.
house price value
Yes.
in machine learning.
Yep.
Yes,
And
we
we
are
will
getting
talk.
it.
Great, great, great. Thank you for so much for confirming this. So I will relate this thing now to the news channel case study that I was talking about as well. So over there, what we did was, even though I'm not allowed to specifically tell you what are all the steps that I have taken to, for that product decision to launch that particular education product into the market, I may not be, allowed to do that, but I can give you a vague description of all the things that I have done over there. And the first thing that we did was we took the entire data of the customers, the town's location, the people's geolocation, and we interpreted that they use a different software. I'm using over here Python, but they used a different software over there. And we used the same analysis. We plotted all the customers' data on a map and analyzed, okay, at which place I am making more profit. And at which place, I should avoid, which place my newspaper is selling more, which place my news channel is, conducting more. And accordingly, we need to advertise it as well. So take a look at this graph and take a look at this kind of legend as well over here at the right side. This legend tells you the colors from yellow to bluish. So bluish is like a house price value of around 50,000, and these yellow or red houses are the expensive houses. So these towns now, they individually, the color individually tells you how much the value of a particular house is in that area. And the size of the circle of these individual markers indicate the population. So if the circle is small, the population is small. If the circle is very big, the population is big as well. Like you can see population 5,000 for a bigger circle. And if I hover over a small circle, you can see population just 200. So the point is, this is called exploratory data analysis. When we understand the data, when we understand, okay, this is our customer base, and these are how many customers I have in this place. This is how much my customer is going to profit me, and stuff like that. So these are the initial principles of data science. And what we did was we just summarized the entire data. You see, to be honest with you, I don't even use Excel in any of my workflows. It's just that I have displayed this information in Excel just because for you. Because rather what we do is we use specific kind of softwares and summarize all the data just like that. So I hope we are good at this stage. Guys, let me know if everyone is on board and know what we are talking about. I saw someone unmute their mic. Please confirm if you are good.
Yes.
All right, Ash. So, okay, that was the first thing. So, take the data and transform it in a way that is useful to you. Useful in sense that you can, take decisions on. And the point is decision making. See, at the end of the day, you can hire other people for tech. There are a lot of people who speak a lingo of tech. But at the end of the day, what gives you profit? Decision making, right? Good decisions, good profit. Bad decisions, no profit at all. So that was the first thing. And the second thing was to analyze, okay, let's consider a problem statement. If I would like to purchase a house in here somewhere, so can you recommend to me what house should I buy and how much that house should sell for? In the same way that the news channel offered to me that I want to sell this product, but in which school should we offer these services? So in the end, what we decided was that we should target South Delhi's school first. I live in Delhi. So specifically in South Delhi, we were targeting some specific schools, and accordingly we use these kind of models as well. And what is that model that I'm talking about? This is the model. Take a look. This is all the data. So according to the geolocation, latitude, longitude, how old a house is within a particular town or a residential area, according to these many things, you see the prediction will change. And this prediction is about your dream house would cost approximately 170,000, or in this case, very close to 170,000 approximately. If I change these figures, you see the prediction change. Guys, can anyone confirm? If I change the figures, the prediction is changing.
We can't see you, your desktop. We can
Oh,
see you only.
okay, okay. I'm so sorry. I'm so sorry. I was supposed to be sharing my screen now all this time.
Yeah,
Maybe I had, but maybe some kind of glitch happened. What did this happen? Do you guys have my
yeah,
screen?
visible.
Thank you so
Yeah,
much
yeah, visible
for
now.
confirming. Thank you so much, guys. And I was showing you this kind of graph before. So, do you have the visual of it?
Yes.
Yeah. So the point I was trying to make is that we had, I need to start all over again. But take a look. Initially, what we had been given was just this data of latitude, longitude, housing median age, and total rooms. And basically, the individually all the rows, no, these are just the town's location. Like town one has these parameters. Town one has these geolocation parameters. This is the median age of that particular town. And I'm basically saying town, but in an advanced area like this, I should call it a residential area. So the point would be that in this particular Excel sheet, I have around data of 20,000 residential areas. I cannot read the Excel file just like that. So what we do is we use specialized software first of all, and we summarize all of the data. This is part of EDA, exploratory data analysis, and we analyze it. And just you can see that just through a very simple geolocation map, we have simplified a lot of details, and we have all the data right here with us. Can you see this, guys? Am I sharing my screen?
Yeah,
Yes, yes.
yeah, yeah.
Yeah, great. Thank you so much for confirming. See, this is why I initially asked the question if I'm sharing my screen or not, because I kind of get just that a glitch was happening around here. So anyway, this is the basic. I mean, see, the plot is very basic. It's a geo plot. You can use Google Maps or maybe open source other software there are. But the point is, what kind of problem statements am I solving with this thing? Imagine that. Like, let's assume that individually all the markers are going from blue to yellow, and blue houses are around $50,000, so affordable houses, and yellow houses over here. Yellow houses in the legend, look, yellow houses will be in the range of like 400 to $500,000. So think about it, that in this visual, I am, the house prices are differentiated by colors. So in the first look itself, I have the entire information about the data. I don't need to look at all the rows of Excel now. I can just take a look at this very simple visualization and okay, check for myself which are the places in which more affordable houses are and which are the places in which very expensive houses are. So we can analyze it right away as well, like the reason why some houses are expensive, the reason why other houses may not be so expensive. Just zoom in and you can see all the houses which are near a water body are expensive. I'm sure you can see this thing now.
Yeah, yeah, it's visible.
Great. Thank you for confirming. And this was the first step, like how you transform your data into something that is useful to you. In this case, visual is something that is very much interpretable by us humans, very easily interpretable. We can delve into the data set itself and ask ourselves a lot of questions around the data itself and figure out. And the second part is how do I solve a particular problem statement around it? Maybe I want to segment a customer based on a residential area. Where should I target more of my newspapers or maybe news? Or if I have launched a new product, where specifically should I target it? Should I target it in a very affordable colony, or should I target my product in a very in a place where very rich people live? So problems of these kind arise all the time, and to solve those problems, we don't, then again, we don't go to the Excel sheet and find the answers like that. No, we don't do that. We create machine learning models. At this stage, imagine that machine learning model is just some kind of computer intelligence at this moment. Just we can just take that as a definition. Machine learning model, just some kind of computer intelligence that can read through all the data that you have available and would tell you the answer accordingly. So the question goes like, if I want to purchase a house in California, then if I specify its geolocation, okay, this is the place where I would like to buy my house, latitude and longitude, longitude location. Housing of the age, like median age of the house. How many bedrooms should I want in the particular town? Do I want a town which is very much isolated, or do I want a town where a lot of people live? We can specify these kind of parameters, and you see, according to all these parameters on the left-hand navigation panel, these predictions will change. That's the magic of machine learning. Machine learning is like read through all the data, find the patterns, and give you the answers automatically. Of course, I will simplify it for you should the time allows. But guys, let me know if I change these parameters. Can you see the change in the predictions as well?
Yes.
Right?
Yeah,
So,
changing.
yeah, great. So see, the landscape of data science within my tenure of work has changed a lot as well. Initially we used to make these kind of things like visuals, machine learning models back in 2015. I'm talking about, but nowadays data science has advanced so much that learning these kind of things are like very basic things. You need to learn have a basic gist of a little bit more, because data is not just available in a format of numbers. Think about it this way: if you have an image, don't you think it's a data? Take a look, it's the image of three, right? Don't you think it's also data? Take a look at this sentence. Don't you think it's also data? The point I'm trying to make is that with respect to the news channel I was talking about, what we were about in that particular place was thousands and thousands and thousands of people have their own reviews on Twitter, on maybe their own website, and they also did their survey. There were thousands of reviews, textual reviews, and it's logically impossible to have people assigned to read all the reviews yourself. So what we do is, in those cases, we train a machine learning model which can read all the reviews by its own, and the model is able to tell, okay, which are what steps I can do to make my purchase better, make my sales better, to increase my sales. This is the place where I need to target. This is the customer segment which I need to target. So the point is, when we are talking about reviews, that's a textual data like this. And when I'm talking about images, that's also a data. So unlike in 2015, where we used to mostly deal with numbers like this, the landscape has changed a lot. I hope you guys are following what I'm saying about the reviews and stuff. Let me know, guys.
Yes.
All right, great. So the point is, the particular thing that I'm referring to at the moment is sentiment analysis. So in sentiment analysis, we have problem statements of the kind. If you have product reviews, can you, in a very quick manner, can you suggest some changes to me if the product was received well in a place, or if a product was not received well in a place? That's also data science. And then again, when we say we are training machine learning models, when we say something like ChatGPT, I'm sure a lot of you have used or heard about ChatGPT, right? Could someone confirm if they have used ChatGPT, or would you like me to say to show you what ChatGPT is?
No, we know ChatGPT and and we also used it every day.
Yeah, right. So see, tell me just one thing. When you use ChatGPT, it looks like magic, right?
Yes, sometimes.
Sometimes, right? Let me tell you, not just you. A lot of people think about AI as if AI is a digital being which is capable of doing superhuman feats. But that is not at all the case. All AI in this case, all ChatGPT is doing is it takes string data like this. String, I mean textual data like this, convert it to some kind of numerical form, just like this. We will talk about it should the time allow us. See, in this case, we have textual data, early to bed, and it has been represented to us in a numerical form, and then it converts the numerical form back to some kind of string again. So if we ask the question to ChatGPT, first of all, it takes the textual data, convert it to some kind of vector like this, in this case, a vector of 0 and 1, or it could be a vector of decimals. Vector, I mean that just a collection of a lot of digits. And a lot of pre-processing happens. But at the end of the day, it's not magic. And I hope you guys are getting the gist of what I'm saying. So the point is, I'm using the words machine learning. I'm using the words, maybe I've used deep learning as well. So I've used the word AI, artificial intelligence. Maybe if you know, maybe if you don't know, let me tell you, AI, you can just imagine, is a mathematical magic, which we use in the field of data science to ease our workflow of the kind, like to make this application. The application part was very simple. Application is just a part of web development or software development. You have a team of when you work with startups and stuff, you have a different developers team. So application is just one step away. It's always the decision making that the business is revolving around. If decisions are good, business will profit. If decisions itself are bad, then no profit. So the point is, initially in 2015, a lot of data science workflows used to be very much manual. Very much manual in sense like you need to write a lot of code, import this into Python. You see, it's the same data, and do a lot of mathematical and statistical analysis. But right about 2016 or 17 or 18, machine learning took over, and a lot of these things were automated. Automated in sense, let me show you. Like if someone has heard about it, data pipeline, a lot of pipelines were being created so that all the things if the data is updated, then accordingly the machine learning models, the chatbots we create, the chat GPT that is there also updates its output pipelines of this kind of thing. So in back end, a lot of things is happening. Our initial numbers of latitude, longitude, age, and stuff like that are being transformed into entirely different space. I'm not even able to read this thing anymore. Like this is negative 0.941. I don't know what this digit is, but it's the same data as this thing. So point is that data science workflows have already been automated, and it's called machine learning. Machine learning is the art of how the machine learns to understand the pattern of the data, to understand, okay, what the user want. If you have some sets of features, some set of features on the left navigation panel, what do you need to output? Like output would be something like this. So a pattern would be if you were to read the Excel data on your own accord, it would have been taken you a long time. If you multiply digits like 724 multiplied by 1111, it would take you a long time, but use a calculator, it will happen in a snap. So machines are good at calculations. So I hope we are good at this stage. Case one clear? Guys, let me know. How do I full screen it? Guys, are you here? Please let me know. Am I audible, guys? Please let me know.
Yes,
Any
you are
questions?
audible.
Audible. Could you please tell me how many participants there are at the moment? I'm not able to open Zoom.
They just start learning data science, and machine learning is quite tough for me. So I just know the things, but not getting the point exactly.
Okay. Great question. Great question. So I hope you at least got the gist of this map and stuff.
Yes, map and stuffs and data I know because we are
Mhm.
practicing on this data so much, like California housing. So I see this data very much closely, and actually we work on it so many times by taking the data which we need, the useful data from the set, overall set.
Mhm.
We are not using the whole data, right?
Yeah. Mhm.
We are taking the important stuff
Yep.
for actual the
Yep.
relevant data for the exact what output,
Mhm.
right?
So you're saying like you find it troublesome to get into the machine learning aspects of it, right?
Yes.
You don't find the point of machine learning. Let me simplify. I was just coming to that point, but I was just asking the audience if they are still there. So anyway, let me take a very easy example to explain to you machine learning in simplest of the words. Because you see, no matter the kind of problem that you face, if you are able to simplify it, then it would mean that you understand the problem statement at its root. And when you understand the problem, basically, you can simplify it in your own words. So as much as you can simplify it, the more confidence you would have. Okay, I know this kind of stuff. So we will take this very simple example of work experience versus salary. So in a traditional rule-based system, we could say to Python something like, if the work experience is 1, the salary of an employee is 1,000. If the work experience is 2, then 2,000, 3,000. I hope you got the gist of the data. Very simple data. I know it doesn't make sense, but just trying to clear a point.
Yeah, getting the data.
Great. So see, as humans, if we try to visualize it, what was the first step? Take the data, visualize it. Blindly just visualize it. If it's a geomap, make a geomap out of it. If it's any kind of data, make univariate plots, bivariate plots. I may not have used those terms, but we may, if the time allows us. So see, I have only done the visualization of it, and as a human, I can watch the pattern going up. So if someone were to pose a question like this, if an employee with 4 years of work experience come in, what do you expect their salary to be? 4 years, mind you, 4 years they are here. Have you noticed the pattern? Can somebody answer this question? 4 years of work experience, expected salary.
Yeah,
It's
the
just
4,000 would be the
yeah,
4,000
it's
would be the expected salary in that
yeah,
case.
exactly. But the point is, you are a human, you are able to tell it. Maybe AI is able to tell it. But traditional AI systems are written in a different way than how we perceive it. We perceive this data in a patternized form. We saw the pattern and we saw like it's a linear pattern going up. But for a computer, a rule-based system would be something like this. There are only 3 points, there are only three rules: one 1,000, two 2,000, three 3,000. And that's all I know about the system. That's what I'm talking about in a machine way. So if you were to ask the question of the kind 4,000, machine would give you an error. So how do we use the principles of AI and machine learning in this case? If I were to write the same thing over like this way, salary equals work experience times 1,000. Don't you think a simplified mathematical equation can give you all the answers? Give it work experience of 4, the output will be 4,000. And this is what the salary is. Basically, we have achieved some kind of intelligence. And in this system, no matter what kind of work experience you give, it will give you the output as salary. I hope we are good at this stage.
Yes.
Great. So at this point, at least in this point in machine learning lingo, this is how we would say it. We have defined our entire data, our entire world of data in a mathematical space of salary equals work experience multiplied by 1,000, which is nothing but a mathematical equation representing the kind of y equals mx plus c. Or maybe you may see other people writing the same equation as ax plus b, or maybe there are some different lingo around it. But the point is, I have summarized the entire world through just mathematics. And as long as I can summarize the entire world through mathematics, I have, answers for infinite problem statements, as long as the problem statement revolves around work experience. In this system, if someone were to ask me the question of the kind, I have done 10 more projects. So tell me the expected salary. Now this system will blow up because in this hypothetical case, all the system has seen is work experience, not the kind of projects. So we can expand this mathematical equation then do something like this kind. Salary equals work experience multiplied by some kind of constant. Maybe in this case was 1,000 plus number of projects, number of, let's say, project multiplied by some kind of constant too. The point is, as long as you can define your entire world space through mathematics, if you can define your feature space through mathematics, you can gain intelligent sort of systems. And this is the kind of same kind of equations that I have used over here as well. So in the data, the in the data itself, the information that I'm passing may contain, let's say, 13.54, may not contain 13.54 as well. But because I'm using equations of this kind, I am achieving an intelligent output. So I hope you have the intuition of what I'm saying. Like through mathematics, we all solve it, guys.
Yeah.
Please counter question, yeah. Please
Yeah.
counter question. Because the
Through
more difficult your
yeah
question would be, it will be better. Yeah, go on.
yeah through mathematical equations, we can also expect the salary for that person whose data is not there.
Mhm. Great answer. So the point would be now that we have, we were using the 1,000 as a constant, but where does this constant came from? The equation was as simple as this kind: y equals mx plus c, or more specifically, m was 1,000, x was a work experience, c was we took the c to be 0. But where did this 1,000 came from? I mean, we are humans; we can decipher the patterns from the data itself. But machines, how do machines do that? If we can find a way to teach a machine to find this kind of pattern, we have achieved artificial intelligence. And let me just show you a very basic script of how we do that. In the real world, trust me, in the real world, we do have technologies like AI and deep learning, very fancy algorithms. But this straight line equation is always where we start from, because this the more simplistic your problem is, the more interpretable your results are. And we are after not accuracy, but interpretable results. So this is where I was. 3 data points, cross a line through it, and cross a line through it, and you have achieved all your answers. But how would a machine know? First of all, machine would create a random set of like this way. Yeah. Is it visible, guys? And let me know if you're here,
Yes.
right? So
Yeah,
what
yeah,
would happen
visual.
is,
Yes.
great. Thank you so much for answering. So machines would rather, what they do is they make a random suggestion first of all. Random suggestion, like they created a random line first of all. And the random line, making a different prediction. So these violet points are the actual values, 1,000, 2,000, 3,000. And the green points are the predictions of this line. So at this point, my machine learning model has not learned anything at all. My machine learning model is saying that no matter the work experience, my salary is always zero, which is kind of stupid to think. But think about it in the machine's way. I'm teaching a newborn child. This newborn child has not learned any kind of language. The things I'm going to teach is what the things it's going to retain. So initially, machine has drawn for us a very random line, straight line with the simplistic answer that no matter the kind of work experience you bring in, the answer is still zero. So we record the errors. These errors are represented by the yellow lines. And I say, okay, my random prediction caused me this much of error. Now, the next step would be how can I decrease the error? So I went ahead, and in the second iteration of the same process, I will make a different line, and you see the error is reduced. So initially the error was around, I believe, 2 million. You see, error was initially 2 million. Error matrix could be anything. It could be, just take the summation of the errors or square the errors up. There are different metrics. But the point would be make a random suggestion first, calculate the error, and in subsequent iterations, try to reduce the error. This is how the machine learns. And eventually, the machine will learn the best line, and that is called the line of best fit. And as humans, we saw the pattern right away. Where was it? Right away, we as humans saw it. But it took machines some time to reach that particular stage. But think about it. Let it be machine or let it be you humans. We all reach the same conclusion that this is the line that best fits the data, isn't it? Guys, please let me know.
Yes.
And could someone here clear to me how do I like full screen it? I'm not able to see it, like how many participants there are and meeting info. Should I click on it? I'm actually using, I'm very much used to Google Meet and our own subsequent meeting platforms, but I'm using Zoom for the first time. Anyway, this was the gist of machine learning. And the point that I was making was back in 2015, it used to happen like we would receive data in this kind. But now what happens is companies would, what the data science industry is moving into is the trend of companies would have documents, well-written documents, files, physical files over there. And what we would do is we would take snapshots of all the files and we will create Excel sheets out of it. And all the process are automated. So the point is we are now dealing with image kind of data. And in the image itself, there are a lot of information. Maybe think about a software of this kind that you are going to a different country, say China, and you don't know Chinese, but there is a restaurant board over there, and you take your mobile phone up and you click the photo of that board, and the camera app itself is able to translate Chinese to English for you. So there are so many things happening. First of all, you click the image of this kind. Then image was transformed into numbers, and then numbers through the numbers, the pattern was learned. Machine learning models try to analyze the pattern through straight lines, maybe advanced mathematical equations. But you took an image, some kind of pattern was taken out, and the pattern then was converted into some kind of language. Then inside the image as well, you recorded, okay, this is Chinese. I want to take the Chinese text and translate it into English text. The point is, we now have the data in images, but as well as in the format of language as well. And there comes the specialized field of computer vision and NLP for natural language processing of a natural human language. But at the end of the day, It's all mathematics, like I have just shown you. If you have a pattern, cross a straight line over to it, maybe straight line, maybe a not so straight line. But the point would be, if you have image, if you have textual data, convert it in a way you can analyze. So if you have, string kind of data, textual data, convert it in a way you can use mathematics on. I have taken the textual data early to bed, and I have successfully converted it into numbers. And as long as we are dealing with numbers, we can perform the mathematical AI magic. So when we think about AI, it's not magic at all. This is all the stuff that happens. And to be honest, you don't, do all these things when you, as a fresher, nobody expects you to do these kind of things. But let me stop here for a moment, and I'm opening the line for Q&A. So guys, if you have specific questions, please ask. Guys, are you here? See, the my motivation for this session was that this 1 hour session, helps you in some way. Maybe I'm able to give you some of my experience, some of the things that I know. I would like to help you in some way, that this 1 hour session helped you. So please let me know if I was successful in that or not.
Yeah, we got it till now. But my point is, when we learn everything, how to convert data, how to use codes and everything, but
Mhm.
what about the decision taking? Like we learned the data, we analyze the data, everything, but what type of analysis or what type of decision we need to take to further take final decision? Like what kind of tree or what kind of codes we need to use,
Okay.
the
So,
decision where human need to think
all right.
after analyzing the data.
I got your question. It's a very good question. So the someone in the audience also said that they have also used this housing CSV a lot of times, right? So the decision making happens in the statistical parts, where what we say is, okay, let's imagine that the current process that our company has, it's giving me around 80% accuracy in the language translation. Let's just take a case of language translation. So maybe Chinese to English kind of language translation is happening, and the current system is able to perform, let's say, 80% accurate. And now I have successfully created, let's say hypothetically, I have successfully created a new way of language translation, which is able to hit 81%, 1% more than my active algorithm. Then the decision making would be: is your 1% worth it to reinvent the entire infrastructure? Is your 1% gain factual, or is it by chance? So we use statistics of these kind, like what's the confidence interval, how sure you are that you have achieved this kind of more accuracy, not by chance, but it is a fact. I have laid down a lot of tests, and I'm 95% sure that my accuracy will be better. But in more often than not cases, 1% care, the accuracy improvement is not justified. That is one part. And the code that's we personally use would be something like stats libraries there in Python. So stats.t.interval. We use something of the kind hypothesis testing, like you usually have a sample to go with. You don't take the population of the data. So you measure, okay, if the sample is representing the entire population of my user base. So question of that kind come in. Any follow-up question? Yeah, please go ahead.
So we need to take data, analyze, and do testing, and then predictions, then check the accuracy. So how many time we need to do all these? Like if I'm getting accuracy only 70 or 75% accuracy, then we need to reanalyze everything or redo everything to gain more accuracy.
See,
Like
first of
I'm
all,
just I'm
go
just
on.
trying to ask, like an experienced data science person uh, would be doing everything once or twice, like testing purpose,
Okay,
like
okay. Let me
research
give you a
and
very fresh
analysis.
example.
So how many times it it takes?
It
Like
happens a lot of times. Let me tell you the story with that news channel. So, without getting into the specifics, it should be around 30 to 40 times that we had to retrain the models again and again and again and again. Because first of all, we looked at very simple model, very simplistic, very
mhm,
dumb kind of models, just so because we could understand the data itself. The particular algorithm and interest that I'm referring to is linear regression, the straight line kind of, because linear regression can tell us coefficients of all the features that we are using. So as long as we understand the data, so
mhm,
linear regression
mhm.
was, if I'm right, it was predicting around 30, 35. In the real world, no, that's the accuracy figures that we hit. It's in only the sample data that we are hitting the accuracies of like 70% or so. So linear regression back then was able to hit like 30, 35. I don't remember exactly, but it was in the figures of 30 to 35. But then we transformed and, it was a number prediction game. So we were dealing with regression only. So after that, there were different like SVM we used. What else was there? Decision trees, random forest we also used there. But finally, later on at the end, we stuck to linear regression only, even though the accuracy was poor, because the results were very much interpretable. We knew even if the accuracy is low, we knew that okay, I am sure I can read entire linear regression. I can understand the statistics of linear regression. So we also trained our basic, what do you say, deep learning models with TensorFlow and Keras at the backend, if you have heard about those two. But we didn't go into that. We just chose the first algorithm we used. But do know, we tried almost 30 different algorithms. And it took around 1 month, not just for the training, but for the implementation, retraining, and so and so and so. And there were a lot of decision making in the end. Like even if you are able to achieve the accuracy of 50 and above, is it justified? Can you explain it? I was not able to explain it. You cannot explain black box deep learning models at all. So, any follow up question? I hope like I was able to give you some insight.
Yeah,
Yeah.
very
So,
much. Thank you.
thank you so much. Any other question? Praveen, was it right?
Yeah, it was me, Praveen.
Great. So, anyone else, guys? Please let me know. Otherwise, we wrap up the session. Please, I would like to engage more with the audience. And guys, see, even if you are watching the recording, just let me say it. If you are a very complete fresher, just graduating out of the college, or if you are a MBA aspirant, no, data science will become more important to you, because data science is not about tech as we think. Because like I may have told you that I started my career back in 2015, but I had no sense of tech at the moment. But you could say I was good for decision making, because as a co-founder you have to be really critical about your decisions. So the thing about decision making still has not changed. Yeah, I am not even a good programmer, but the point is now I am able to critically evaluate my decisions because of data science. So even if you are MBA aspirants, some kind of knowledge, basic knowledge of data science will help you out. And uh, I think that's about it from my side. So guys, let me know if you have further questions. Otherwise, we wrap it up. There was one person as well who asked me the question that they are facing some kind of problem with machine learning itself. All right, let's wrap up. If no follow-up questions are there, thank you so much, guys. It was great interacting with you, especially you, Praveen sir.
Thank you, Abhishek. Thank you very much.
Thank you.